Welcome back. In this video, we are going to solve example 1.7 that is taken from chapter number 1 stress, and book name is Mechanics of Material by R.C. Hibbeler, and its 9th edition. So statement is the casting shown in figure 1.17a is made up of steel having specific weight of steel is 490 pound per cubic feet. Determine the average compressive stress acting at point A and B. So you can see this is a cylindrical rod that is casted there and it's made up of steel. So at this portion you can see at point A and at point B you have to determine the average compressive stress at these 2 points. So let's start with the solution. So first step is that when you cut this cylindrical rod at a length of 2.75 feet from the top and draw the free body diagram, so it will be like this. So this 2.75 feet steel rod will having a weight which will act downward at this point. So this force, which is the weight of this rod, is acting downward, and this W of steel will be equal to specific weight of steel multiplied by volume of steel. This is volume, and when you cut it you will be having a reaction force downward which will cause compression in this, and this load will be equal to P. So we will apply equation of equilibrium that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see W of steel which is acting downward because weight is the force which is always acting downward toward the center of gravity. Okay, and P is acting upward, so their sum must be equal to 0. So it means that your P will be equal to weight of steel. That this is your equation number 1. Now we know that we have been given that weight of steel is is not given. We know that weight of steel is equal to specific weight of steel multiplied by volume of steel. Clear? And volume of steel that is taken from this figure, since it is cylindrical, so we know that its volume is area multiplied by the length of cross-sectional area multiplied by length of the rod. So here you can see the cross-sectional area is this one, so its radius is given as 0.75 feet. So area, cross-sectional area of circular will be equal to pi into r square. So pi multiplied by 0.75 square, and the length is 2.75 feet. Clear? That will give you volume of steel. Now if we multiply this with gamma, so it will give you weight of steel. So weight of steel will be equal to gamma. Gamma is equal to 490 multiplied by volume, which is equal to pi multiplied by 0.75 square multiplied by length, which is 2.75. So put value of W of steel in equation number 1. So you will get this P will be equal to W of steel, weight of steel, which is equal to 490 multiplied by pi multiplied by 0.75 square multiplied by 2.75. And when you solve this, you will get this compressive load will be equal to 2381 pounds. Now you have this load, so we have to find the average compressive stress. So we know that average compressive stress is equal to compressive load divided by compressive area. So load is 2381 pounds and the compressive area is this one, this shaded one. So it will be equal to pi r square. So pi multiplied by r is 0.75 feet, so 0.75 square. So when you solve this, it will be equal to 1347.5 pounds per square feet. So this is the average compressive stress, that is equal to 1347.5 pounds per square feet. Now if you want to convert it into pound per square inch, so 1347.5 multiplied by pound, so we know that 1 feet is equal to 12 inch, so 12 square will be into 12 12 will be equal to 1 feet is equal to 12 inch, so 12 square into 12 inch. So then what we will get is that average normal stress in compression will be equal to 9.36 pound per square inch, and that will be equal to 9.36 psi. 9.36 psi, which is the answer of our this question. So what if I draw this lower base of this rod? Clear? So this stress will be this compressive stress will be acting like this. It will be uniform throughout its diameter. Clear? So we get that average normal stress at point A and C will be equal to 9.36. And that was all about this problem, example 1.7. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Also, one more thing is that if you want to represent this stress at this element, clear, so that will be like this. This will be 9.36 psi. That will be in compression. Okay. So that was all about this problem. Thank you for watching.